this demo is to just give you a visual representation of what is going on during equilibrium in a reaction. So what I'm about to place into this test tube is water, phenolphthalein, and concentrated ammonia. So it's only a couple drops of concentrated ammonia, but as you can see, the solution is a pretty bright pink, probably somewhere around this range, so a pH of probably 9.5 to 10. So that's the pH of the current solution. So as I mentioned, this is our solution with water, phenolphthalein, and concentrated ammonia. So as you can see, the color is very bright pink. So I'm just going to pour it in here to make it a little easier to work with. But you can still see the color is pretty bright pink, and we're going to use this as a background so that you can see better what's going on. So now I'm going to heat the solution. We can think about if we're adding heat, is that a product or a reactant, and then what type of reaction is it going to be? Okay. So as you can see, it's becoming less and less pink. So here is a comparison. I just took the same solution and put it in another test tube, and as you can see, this one is a lot darker than the one we just applied heat to. Okay, so we have been letting this solution cool for about 5 minutes, just because we don't want to put the hot glass into the cold solution. So as you can see, it's still pretty clear, and that's after we've applied heat. And now we're going to put it in just some cold water. So to basically remove the heat and start cooling it off. So what we should see happening is just the dark pink returning. So as you can see, it's getting a little darker. Next I'm going to move it to an ice water solution. The ice is actually melted, but this solution is cooler than the one we just used. Okay, so I think that's about as dark as it's going to get. And as you can see, it's returned to its original color. Okay. Okay, so as we said, we added concentrated ammonia to water, and we had phenolphthalein in there also. So when we added these together, they produced ammonium and hydroxide ions. So these hydroxide ions are what caused the solution to be basic and gave us a pink pH, which we said was around 9.5 or 10. So then remember, we added heat, so since we're adding it, it's a reactant of this forward reaction. And then it's that heat that caused, the increase in heat that caused the reaction to shift this way and thus produce ammonia and water again, and which this water is what drove the pH down to give us a clear solution. So then would this be endothermic or exothermic? We said heat is the reactant, we're putting it in, so this is endothermic.